Network flows. This is a weighted graph which shows the quantity of flow through each edge. So how much can go from one section to the other section. Example 1 here. The edges of this graph represent roads between towns. The maximum flow per hour are. So there they are. We've written them on the diagram already. Part A says find the maximum flow from A to E and it has to go through D.
So it has to go through this point.
Has to go through that. So we can go from A to D and we can take 500, doesn't matter, it says it's road, so let's say it's 500 cars and it says that it's cars. So 500 cars from A to D. In one hit, that's not an issue. Every hour, 500 cars go through there. But then from D to E, we can only have 150 cars going through in an hour. So the maximum flow from A to E going through D is only 150 cars for the hour. Doesn't matter how many we can get to D, we can only go 150 from D to E. Then part B goes like this. A new road is being built connecting D to C. The new road is built can carry 500 cars per hour. What is the maximum flow from A to E? Not necessarily through D. So let's have a look at this. Let's start back at A. From A, we can go up to B and we can get 300 cars there. Not a problem. So we'll just put 300 cars next to the B. Then, we won't do C just yet. We'll wait to get to D because there's two ways we can get to C. So A to D, we've got 500 cars. We already know that. So we'll write that D. And we'll do from D to E because we know from D to E, we can get 150 cars. So we'll just put that down there. Then to C, we can get the whole 300 cars, that coming from B to C, that's not an issue. So we can get 300 cars there. But we've got, at D, we've got 350 sitting there. Because we've got 150 going to E, we've got 350 sitting there at D. We can take those 350 and go from D to C. So now at C we've got another 350 there. So to all up, we've got at C, we've got 650 cars waiting there. And we can take 800 cars from C to E in the whole hour. We've only got 650 sitting there, so we can take those 650 sitting there as well. So 650 there, plus the 150 coming from the E, we have 800 cars that we can get to E every hour. Example 2. It says flights connect the airport at Sydney, Melbourne, Brisbane, Adelaide and Canberra. The numbers in this graph represent the maximum number of passengers that can be carried in a fixed time. Part A says, find the maximum number of passengers that can be carried between Sydney and Adelaide in the fixed time.
So we've got Sydney and Adelaide here, haven't we?
Yeah,
so we can, Sydney, where can we go? Adelaide. We can go through Brisbane.
Yeah, with 700.
Through Canberra and through Melbourne in two ways. So
yeah. And back from Melbourne back up to Canberra. So we've got to look at everything. Okay, so from Sydney to Brisbane, we can take 700. So there it is right
so
there.
There you go, we've got 700 coming through.
Right, 700 right there. And then from B to A, we can get 700. So there we go, 700, not an issue. We can do that. From Sydney to Canberra, we can have 1,500. So far, we've got 1,500 sitting at Canberra. That's not a problem. And then from Sydney to Melbourne, we can have 1,200. That's not a problem. 1,200 sitting right there in Melbourne. Let's do this 1,200. This 1,200, 600 can go from Melbourne to Adelaide directly. So, not an issue. We can get 600 sitting at Adelaide and we're fine at the moment. We've still got 600 in Melbourne. We can't take them.
So
we can take them up to Canberra.
We've got a bit of a backlog here now because if 600 go to Melbourne and 1,500 go to Canberra, we've got 2,100 people sitting here.
But how many can we take from Canberra to Adelaide? Only 400. So we can only take that 400. So altogether we can take the 7, the 4 and the 600. We can take 1,700 people only from Sydney to Adelaide in any particular time. Part B says how can this indicate how this can be achieved.
Well,
we've just done that on the graph
that,
there.
we need to write it down, so we've got...
But if we want, we can do this. 700 passengers from Sydney, so S to B, which is Brisbane to Adelaide. Then we had 600 passengers that went from Sydney to Melbourne to Adelaide. And then we had 400 passengers, and it doesn't matter which way you go. We can go Sydney to Canberra to Adelaide. Whether you go Sydney, Melbourne, Canberra, Adelaide, it doesn't matter. Let's just find the direct route. Now, we don't want to keep doing this. Imagine now we've got really, really big networks. So we've come up with this rule that's called the maximum flow. And to work out the maximum flow, we use this thing called a minimum cut capacity. Now, what is a cut? A cut is defined as a collection of edges that, if removed, produce zero flow. That means we can't get from one spot to the other. So what I like to say is pretend we blow up some of these roads. All right, yeah, we can get to some spot as long as we can't get from the start to the finish. All right, so they can stop in the middle, but we cannot complete our network. The capacity of a cut is the sum, so we have to add up the capacities or the weights on these edges. There is a catch though. Edges that cannot contribute to the flow of a network in the required direction are counted as zero. So anything that goes backwards, okay, or when we draw our cut is drawn backwards, we don't count them. So here's an example of it. Okay, now I can put a cut directly here, and you know that's called a C1.
Cut 1?
Yeah, cut 1. We'll do a cut going like this, that's a cut 2, and we'll explain these in a minute. Then we can do a cut 3 over here, and we'll have a cut 4 at the end. Now you have to look at everything, okay, and this one looks at everything. But let's look at C1. C1 we've got from C to A, B to A, and B to D. B to A doesn't do anything for us, so we don't count that one at all, so we only have to... sorry, no, we do count that when it's going straight up. So we've got the 3, the 2, and the 2. We have 7. So that adds up to 7. Now let's have a look at cut 2, C2. A to D has a 6. Then we have B to A, and we have C to B. We don't need
that one
to count that one there, B to A, because we're going backwards. Between here on our line and here, there we're going backwards, so we don't count that one at all. So we have 6 and 5, we have 11. Cut 3, they're both going forwards, so 5 and 3 make 8. And cut 4, they're both going forward, 6 and 2 make 8. So we have to be able to get
this
that.
one here was classified as a double cut.
Now, maximum flow. If I was to ask you what is the maximum flow that we can do, we look for the one with the minimum cut capacity. In this case, it's 7, C1. So that would be our maximum flow.
So maximum flow
equals the minimum
cut capacity. And the minimum, the smallest amount is 7, and that's why that is the maximum flow through the network.
All right, now, here I've already drawn the cuts in because it will be a little bit hard to sort of try and draw them in freehand. Example 3 says, determine the capacity of each of the cuts in the graph shown, also the value of the minimum cut, and hence the maximum flow. So if we look at C1, we have to include both of those. They're both going forward, so 15 and 20 gives us 35. If we look at cut 2, we've got a 15, 6, 15 and a 20. Again, they're all going forward, so if we add those numbers up, we get 56. Having a look at cut 3, they're all going forward, there's nothing going backwards again, so 14, 15 and 20. When we add those up, we get 49. Having a look at cut 4, the 10 we include, the 12 is going backwards. We do not include that. We put 0 there, we don't include it at all. So we have, and we got the 20. So we got 30 there. And cut 5, we have the 10 and the 15. We include both of those, so we get 25. So 25 is our minimum cut. There it is right there. So our maximum flow equals 25. Because remember, maximum flow equals minimum cut. Example 4, determine the maximum flow for this directed graph. So we're only going to do the one where it is, and this is the cut that gives us to us. We can try everywhere else, but we're just going to do the one that it is. We add the 3, the 5 is out because it's going backwards. We add the next 3 and we add the 1, so we get a total cut maximum flow of 7.
3 plus 3 plus 1 plus the 0.
Yep. And the 0 is the 5, so we get 7. So that's our maximum flow. 24B. Thank you very much.